refuses to give you your commercial message. All right, so back at the ranch here. If you look at this one, is there anything about it that bugs you? Oh, whoa, that's supposed to be that's a plus 30. Yikes, sorry. 39, well, don't all those numbers just look kind of big? Okay. You could divide it by 3, but I actually don't want you to get in that habit with factoring to get to divide. What we prefer you do, if you notice, hey, yeah, they all are multiples of 3, pull the 3 out front as a factor. And so you would say that's 3 times minus plus 10 equals 0. So pull the 3 out front. You don't actually divide it out there. It just sits out front, says hi, hangs around for the ride. Then, okay, yeah, it's a trinomial, no big deal. I'm curious what you all want to try for factoring this one, because I gave you a 4x squared. Where there's 2 and 2, 4 and 1. Come on, I need more than one vote. I heard 2 people say 2 and 2. Okay. 2 and 2. I just want you to see it happen. What factors would I try on the end? It's got to be factors of 10, so it's got to be 5 and 2 or 10 and 1. So, okay, start popping numbers in there. If I put 5 and 2 in there, that's going to be 10. Outsides are going to be 4. 10 and 4. That's not 13. Okay, so that's bad. Try it. Is there any reason for me to flip the 5 and the 2? Since they're both a 2x, no. It's the same, you're going to get the same thing. So I better ditch 5 and 2, so what do you want to try? 10 and 1. I have a feeling I may have messed up this problem when I just redid it, because I don't think we're going to get anything to work here. Because now what's going to happen? It's going to be a 20 and a 2. Boy, that's not working. So you want to try 4 and 1? Okay. 4 and 1 it is. So if I go 4 and 1, let's ditch the 10 as well. Now, you want to stay with 10 and 1? You want to try 2 and 5? Which way do you want to go now? 2 and 5? So that would be 2 and 5. That would give me a 2x in the middle and a 20x with the outsides. Switch the 2 and the 5. So the point is, guys, it takes some trial and error. You're not expected to always get it on the first try. That's going to be 5 and not 2, but 2 times 4 would be 8. Or 5 and 8 going to get me a 13. If my signs are what? Because in this case, if that's a positive 10 on the back, what do you know about the signs? Yeah, they're either both positives or both negatives. So how do you know which one? Both positives or both negatives? Yeah. If there's a plus in the back, you look to the one in the front, and that'll tell you they're both negatives, because we end up with a negative 13. So negative 8 and negative 5 makes negative 13 in the middle. Then we had a debate last block. When I go to solve this, do I do something with the 3? Do I have to set it equal to 0? You can't, it's non-variable. If that was 3x, then yes, you would set it equal to 0. It's a variable. Since it's just a 3, it actually is having no impact here. Just take your factors and solve them. The 3 just gets ignored. So you would only have to set 4x minus 5 equal to 0 and x minus 2 equal to 0. Which means x would equal 5 over 4 or 2. And there are your solutions. Woo! Do you what now? If it says solve, yes. If it just says factor, no. But if instructions say solve, then yes, you solve it down to solutions. And that's what most of this is. Okay, there's a couple, I guess, special factoring situations. I think you'll remember them, but I need to double check that we're going to talk about here. One of those is, what if the middle term is missing? Just gone. You could just go solve that. If you just solve, you actually could go say, hey dude, x squared equals 25. I can square root both sides, which would be plus or minus 5. But I also want to remind you of how you factor that, because we actually will need to factor it for other things later on. Anybody remember the quick and easy way? It's got to be a perfect square number, like 25, 36, 49. It will unfoil. There you go, x plus 5 and x minus 5, because they're conjugates. The middle terms cancel. So the conjugates that work with imaginary numbers still work here. So anytime you see has to be subtracted, can't factor it if it's added. So for example, what if I had given you 36x squared minus 16? I didn't go ahead and solve that, sorry, but if I give you something like that, you would look at it and go, ooh, 2 terms, 4 goes into it. So I could take a 4 out, which would lead me down to 9x squared minus 4. And I'm looking at going, gosh, all of those are perfect square numbers. Yeah. So you can indeed factor it with conjugates, 3x plus 2 and 3x minus 2. So consequently, what are you going to get for answers? Yeah. You're going to get the exact same thing, except different signs, because you're going to subtract 2 and divide by 3. And when you do the same thing on the other one, you're going to get a positive 2/3. So those kind of will work that way. So that's one specialized situation. The other one, I want you to kind of know what to do with. This is the one I most see mess up. It's actually really easy, but I see people go crazy with inventive new mathematics. And that's what if I just give you the first 2 terms of a quadratic. You got the squared term, you got the first power term, and you have no constant number on the back end. You still set it equal to 0. Always. So that would be to bring the 20c over. But how do I factor that? You can't unfoil if you don't have a constant number on the back end. We don't have a plus some number back there or minus some number. You've got to have that constant number to be able to factor into 2 binomials. If it's this case, your only option is to look for what are the common factors I could pull out of there. So what number is in common to both? 4. And what, anything else? Don't they both have a c in them? So you could take a 4c out, which will leave you with a c minus 5. Okay. So when you go to solve it, do you have to do something with 4c? Yeah. Since it's a variable, yes. If it's a variable, you always set it equal to 0. So you'd say 4c equals 0 and c minus 5 equals 0. So therefore, what's c going to equal? 0 and 5. So if you can pull a common factor out, do so. Then if it's got a variable on it, then you do have to set it equal to 0. So it's not that that's hard. It's just that sometimes we get inventive trying to do it the regular way, and it actually doesn't work the regular way. Okay. The 2 other little things we have to talk about. We'll see how creative and inventive you all are. This time, I'm going to tell you the roots to this equation, and we need to talk about that. In math, there are like a bazillion different words to mean the answers to a problem. If you're talking about where it equals 0, they're called the roots. They can be called the solutions. Sometimes they're called the zeros or the real zeros because they're what make it equal 0. Do you see any of those terms, answers? Do you see any of those terms? It's all the same thing. It means solve the equation. The roots, zeros, solutions, it all the same thing. Okay, what I'm doing is I'm going backwards on you. I'm telling you that the roots or the solutions of a quadratic equation were 2/3 and -7. I want you to find me the original equation that has those as answers. So, anybody with suggestions? There's more than one way you can do it. My recommendation, oh, you have to adios. Bye. Run fast. No pushing and shoving. Okay. So when you work these kind of problems, work it. It's a reverse factoring problem. I'm telling you the answers you got were x equals 2/3 and x equals -7. Let's do the easy one first. What factor did x equals -7 come from? Yeah. When you moved back over here, wasn't it x plus 7 equals 0? So you're just turning it back into the factor it came from. Now, the 2/3 is a little trickier, because we would not have had a factor that had a fraction in it. So where did that 3 come from? Yeah, didn't we divide it over here, so it had to have been on the x? So it was originally 3x equals 2, which means the factor was 3x minus 2. Okay, if I now know the original factors, how can I get the equation? Right idea, but you wouldn't factor it, you would. Yeah, we would FOIL it, yeah. Right, I was trying to get the other F word out of you. Yes, we would FOIL it. Not that F word. Okay, factor or FOIL, those are our F words, okay? So yeah, you just take the factors you created, multiply them back together, and you'll have the original equation that that problem came from. So it's nothing more than doing a little foiling action. Now, why am I putting the equal 0 on it? It said find the original equation. If it's an equation, it has to have an equal sign in it. Because we could have just FOILed it together and said, oh yeah, it's 3x squared plus 21x, whoops, not plus 19x, sorry, got to add, minus 14. That would be the quadratic, but it's not an equation unless it has an equal sign. So therefore, you must have the equal 0 on it to make it an actual equation. So that wasn't so terrible. I do that all the time. I go, oh, I want a problem and I want it to get these kind of answers. And then I work it backwards to figure out what equation I need so it'll come out with the answers I want you to have to find. It's all be fun. All right, off to the parking lot. Your application of the day. Don't know that this is necessarily our parking lot, although our parking lot's pretty much rectangular. You take off some of the extra areas we have. So most of the pavement's pretty much rectangular, isn't it? Only a few buildings in the way. This has an existing parking lot that's 100 meters by 150 meters presently. That's the size of the current parking lot. Okay, needs to be expanded. And they want to expand it by adding a strip to one side and one end. add a strip to one side and one end. And they want it to double the amount of area in the parking lot. I should say double existing area. And so your question is, how wide should this strip be? They're going to add the same width strip to one side and one end. How wide should the strip be so that it ends up with double the area? So what would you say, before you don't even think about starting to write an equation, what should you do here so you can even understand what's going on? Draw a picture in math. Drawing a picture is worth 1,000 words. You can look at that picture and start labeling things. You can figure out a ton from a picture. You should always draw a picture. So, ooh, whoops, that wasn't what I wanted. Wrong tool. Let's try that again. Okay, so it's a rectangular parking lot. Ooh, it went crooked. Is it crooked? Or is it me? I'll try a little better this time.
No, you're right, it's just crooked.
Did you see what it did? Yeah. It corrects itself. If I draw a sloppy triangle, it corrects for me. I mean, it's still a little at an angle, but it'll make them all nice and perfect. So, it's a cool tool. So, what do you know about this parking lot? This is the existing parking lot. It's 100 by 150, so okay. It's 100 by 150. And I'm going to do what to it? I'm going to double it by adding where, though. That's the kicker. Where am I adding this extra space? So one side and one end. So I'm going to do it down here where I got room. I'm adding this strip across the bottom and then to one side. And it's going to be the same width of strip all the way. So I've added on an additional piece. And the question is, how wide should that strip be so that it doubles the area? So what are we going to call the width of the strip right now? X. So it's X wide there. It's also going to be X wide down here. So can you tell me an expression for how long the bottom of this green box is? That would be 150 plus X more. And what about the vertical distance? That would be 100 plus X. Okay, so those would be the dimensions of the new parking lot. What's the key thing here that has to happen? What was the big key thing that you know about how much space this has to have? It is double the existing area. Well, what's the existing area? You would have to take the 150 times 100, which would be 1 times 15 is 15, with how many zeros? 3 zeros on there, so it'd be 15,000 square meters of area right now. So how much do we want our new parking lot to have? If it's supposed to double, the new lot's got to equal 30,000. Okay, so can you write me an equation involving the stuff that we have X in, so we can get an equation to solve for X? What do I know about this situation that uses these new dimensions I created? Do what with the 150 plus X and the 100 plus X? Add, subtract, multiply, divide? Yeah, because isn't area length times width? So you would take the length times the width of the new parking lot, and what should it equal? Should it equal 15? Should equal double, should equal 30. And there is the hard part. You had to find the equation. Okay, then you got to simplify the thing. So can I set each factor equal to 30,000 and get my answers? No, you can never set factors equal to anything but 0. Since that's not a 0, yes, we have to FOIL this thing. So, okay, well, we just did that. 150 times 100 is 15,000. Outsides are 150x, insides are 100x. And last for a nice x squared, so it wasn't bad to FOIL it. What would you like to do now to clean it up? Oh, I didn't realize I was over time. Yikes. So I need to clean it up. You want your x squared at the back? You want to bring it to the front? I would bring it up. So that would be x squared plus 250x. What do I do with the 15 and the 30,000s? You want it equal to 0, so yes, you need to subtract the 30,000 out of there. Which, when I do 15,000 minus 30,000, I'll have a negative 15,000. And I'm down to a quadratic, which at the moment, the only way you know how to solve this is by factoring. So these will factor. They'll be fairly obvious numbers. They won't be something hideous. I mean, granted, we're having to find factors of 15,000, but it will be fairly easy. We know the first have to be what? X and X. Okay, I know since it's a negative 15,000, I'm going to have 1 plus and 1 minus. I just don't know where. Okay, how do I get factors of 15,000? Yeah, start thinking easy. What are factors of 15? 5 and 3, or 1 and 15. Okay, but you just have to get the right number of zeros on it, because we have to end up with 3 zeros. And we want a 250 in the middle. Do I want it to be, put 2 zeros here, do 530? That won't work. Okay, by other way, you want the 50 and 300. Okay, Randy says 50 and 300. Can I make a 250 out of that? Yeah, I can, because they're going to have opposite signs. So I know one of them has to be a 300, one of them has to be a 50. Which one gets the plus and which one gets the minus? Because we want a positive 250, so we'd have a positive 300, a negative 50. And then you can go ahead and solve it. Set it equal to 0. X equals negative 300, or x equals 50. Which of those is a logical answer? That 50. Yeah, you would not, you can't split a strip that's negative 300 feet. That doesn't make sense. So yes, we should add strips of, actually I should say 50 meters, not 50 feet. So those strips each need to be 50 meters wide, and they would double the space of their parking lot. Woo, doggies, wasn't that fun?